So, yeah, when you are choosing the right, selecting the right training algorithm, like what do you look for depending on the task you have? And maybe you can mention some of the existing ones you use and advantages and disadvantages they have.
Again, step zero, uh, the algorithm needs to be related to the task, because some algorithms solve the classification problem, some algorithms solve regression, some algorithms solve clustering, and so on. That's the first step. Then, um, based on the type of task and algorithm, um, let's suppose we are in the supervised area of learning. We want to train, we have data available. uh, Ideally you want to solve a problem linearly. Yeah, you ideally want to solve something in a linear way, because linearly solving a problem in machine learning means you solved it very fast. You also have very fast response time when doing inference, and you didn't overcomplicate things. That's the best case possible. Then, if you didn't manage to solve the problem in a linear way, probably your data is not linearly separable or linearly representable. So you need to go to machine learning models that can represent the data uh, with a different function. So not a linear one, probably a polynomial, and so on. And then you go in different type of algorithms, like tree-based algorithms, where you have random forest and XGBoost. Um, and the difference is that yeah, now you can represent the data differently, but then there are other considerations. So is your data mainly composed of numerical features or categorical features? Categorical features meaning, I don't know, you have a column about colors and it has 5 unique values: green, red, yellow. This is a categorical feature. Usually tree based models will work very well with a lot of categorical data, um, because as the name suggests, they build some trees, decision trees, where they split these features to take decisions. So maybe one split would mean uh, green and red were this class, yellow and blue were another class, usually. And it's easy to separate categories, then it's easier to separate numbers, because if you have a column with continuous values from 0 to 1 million, it will be pretty hard to say at 67.53 I did a split, and now I'm taking this decision and I'm not taking the other decision. And that's one consideration. Then you have SVM, support vector machines, in this case. So support vector machines are very good at dealing with nonlinear data, and they can build and represent the data in different hyperspaces, but it's computationally very expensive, and if you have a large data set it becomes very slow. um, XGBoost is not that slow. It also deals good with high dimensional data, so a lot of columns, but it's pretty difficult to tune you have to do fine tuning to a greater extent. I think it's also one of the only general machine learning algorithms that can have transfer learning, which is a great feature, because you can train
Mm-hmm.
on a task and then take the model and adapt it to a different task with the previous learning still intact. Um, yeah, and so on. So again, many angles to approach the problem of model selection. And usually in practice, the approach is you have what's called a grid search, and you have both a grid search of models. So I have a set of models that I want to try based on the problem at hand, and then I have a set of uh, values for hyperparameter tuning, so for optimizing each algorithm. And I'll try each algorithm with each set of possible parameters that I think will solve my problem, and see what behaved the best. Um, so yeah, the more we go into details, the more we probably realize how tough and how much work is involved to have a model and a system in general that makes sense for your problem.
Thank you very much. To my surprise, I understood almost everything. The better you know what you're dealing with, the more accurate you can choose, of course. But as I understood, there is not much competition yet between very similar solutions. So there is always a solution that suits best for your problem, and you don't have to choose between most suitable ones very often yet, right? If it makes sense.
Uh, yes. So uh, usually, yeah, you will have to adapt uh, the algorithm to your problem and to your use case. Uh, Now, indeed, you can solve a lot of problems with the LLMs, but usually LLMs are, in my opinion, overkill for a lot of things. So people just take the LLM and say, yeah, I'll do this with the LLM, I'll also do that, and uh, you build a lot of things around it that could have been solved with probably simpler and easier to implement general machine learning approach or separate deep learning task and so on. Um, this again, it's thin ice. So, uh, as someone that probably doesn't work in this field or didn't interact a lot with machine learning, you can say, for me, it's very easy. I will take this language model and I apply it to XYZ, and it's reusable, it's great, but in reality, that large language model will solve your XYZ at a higher computation cost, higher maintenance cost, uh, medium quality, and so on. And in reality, you could have solved X, Y, and Z with three simpler models, way cheaper to maintain and way faster when using them, and so on. So, yeah, in reality, most probably you will have to adapt something to your needs, but that's not the goal. If indeed there is something that is reusable for your use case, that's perfect. Less implementation time, less overhead. It's a balance at the moment, I would say. There are things that can be easily reused between companies and industries and so on, and half of the time you will probably have to adapt something to your needs.
Yeah,